Hi everyone. I've got one last video here on some review of just the basics of graphing quadratic functions, finding intercepts and the vertex of quadratic functions, that sort of stuff. So last one here I want to walk through is in factored form. We've already put some of our other examples into factored form, but let's get into this one a little more. So this starts off in factored form. The first question I have here is, what is the y-intercept? And again, if you're not in that standard ax squared plus bx plus c form, you're going to have to do a little bit of work here. So you want to let your x equal 0. And actually, we don't have to do a lot of work here, because if x equals 0, I get negative 2 times 0 times negative 3, which is just 0. So it looks like my y-intercept is actually also an x-intercept. My graph crosses through the origin. So we didn't have to do a ton of work on that one, but in general with factored form, you will have to plug x equals 0 in and do a little multiplication to figure out your y-intercept. X-intercepts of the graph, this is the part you should get for free pretty much. So in my head, I'm thinking, okay, I would let y equal 0, which gives me 0 times negative 2x times x minus 3. 0 equals negative 2x times x minus 3. Because this is already factored, I just look at my individual factors and say, okay, what makes negative 2x equal 0? Well, x has to equal 0 for that to be true. What makes x minus 3 equal 0? X has to be 3, which means my x-intercepts are 0, 0, which I found before, and 3, 0. Okay, so again, the freebie from factored form is the zeros. You should be able to spot your x-intercepts really easily if your function is already in factored form. For the vertex and the y-intercept, you may have to do a little work. But there's a really nice strategy for finding the vertex. If you have a nice factorable quadratic that has fairly easy, straightforward x-intercepts, a good trick to remember is that the quadratic functions are parabolas. They're always symmetric across the vertical line through their vertex. So if you find two x-intercepts of this graph, here we can do a rough sketch even with what we've got right now. We know that it crosses through 0, 0 and 3, 0. Because if we multiplied this out, and you don't have to do it, but just to make sure you're all seeing what I'm talking about, if we multiplied this out, we'd get a negative 2x squared plus 6x. So because the number in front of x squared is negative, this is going to open down. So I can get a rough sketch already. This is going to do something along these lines. So here's the axis of symmetry part. If you know both of your intercepts, your vertex always has to be exactly in the middle of the two. So if I have an intercept at 0 and an intercept at 3, the vertex has to be at x equals 1.5, x equals 3 halves. I will still have to plug back in to find the y-coordinate of the vertex. So I will take my h and I'll plug in a 3 halves, which gives me negative 2 times 3 halves. Times 3 halves minus 3. Okay, so out in front, I get a negative 3. The 2's cancel. Remember, this is a 2 over 1. And then this was 1.5. So 1.5 minus 3 is negative 1.5, which means this is a negative 3 halves. You can also do the common denominator there if you want to make this 6 halves. So we are getting a positive 9 halves. So our vertex is at 3 halves, 9 halves. So right here, 3 halves, which is 1.5, 9 halves, which is 4.5. So there's a decent sketch. And I actually want to go back to the trick we use for finding the vertex in standard form. I mentioned that you could memorize this formula. This formula is actually using the exact same trick I just used. If we say that our vertex is always exactly in the middle of our two x-intercepts, remember that your quadratic formula tells you your x-intercepts. So this is for the vertex. This is for the intercepts. It's actually really easy to spot what should be right in the middle of your two intercepts, because what we're doing here is we're taking, we can even split this fraction into 2. We're taking negative b over 2a, and then we're adding and subtracting to get to our x-intercepts. So we will go b squared minus 4ac, square root of b squared minus 4ac over 2a each direction to find our x-intercepts, which means this is the middle of the two x-intercepts. So if you ever have trouble remembering that, it's really just that first part of the quadratic formula, the negative b over 2a. The plus or minus tells you how far to hit your x-intercepts. All right, I think that's all I have for this one. Let me just peek at my cheat sheet. So again, what I would say for this is hopefully quadratics are review. So this is just kind of a checklist for some of the little things to be watching out for. So just look this list over, and if you're not sure what I'm saying anywhere along the way here, just check in with me. All right, I think that's it. Thanks for watching.